Hello friends. Today I am here again with an interesting topic. If you watch my channel, you know about the Smart Cars project I uploaded before. Today, I will be sharing with you some of the basic techniques I use in these projects. I'm sure it will interest you. These techniques are at least slightly related to artificial intelligence. I hope it will be useful to you and you will use similar techniques in your projects. Come on then, let's do something interesting. There are some necessary objects in our scene. Outer walls, inner walls, and a track, as a ground object. In rigid body tags, the wall objects must be static meshes to get rid of the bounding box issues, as you saw in my previous tutorials. The friction and bounce values are not that important here. Use any values you wish. We will take care of the friction of the ground object. Just increase it for vehicle's road grip. Again, as I explained in my previous lessons, we will use the compound rigid body option for the body and wheels of the car. Because there are different objects under each of them, and this will be essential for the continuity of the movements. For wheels, increase the friction too. These are my engine values in this simulation. Yours will probably be different. These are my values for connectors. These values are appropriate to prevent the car from skidding too much. Now, let's run the animation and check if all this works. Yes. It's like we saw something. We will need some sensors, so that the vehicle can detect walls and other objects, if any. We will use null objects for this. Let's take 6 null objects and make adjustments as you watch. Names, colors, shapes are up to you. Now, put them under the body object and reset their PSR to center them. Let's lift them up a little, to half the height of the walls. Although each model is different, for now, follow the alignments you see here. Null objects ending in number 1 will be in the center, others will be a little further away. Right null objects will check the outer wall collisions. Left ones check the inner wall collisions. Middle nulls will be used later. Try to keep the mid-2 null object a little far away from others, for a good reason that will happen later. Now let's make our first Xpresso settings. First, let's assign an Xpresso tag to the truck object. We will use the steering angles for connectors. Drag them into the editor and select the steering angle items. Then, drag the motors into the editor. We will use the angular target speed option. For speed up the things, I copy them several times and drag and drop the needed ones for each node. Be careful when doing this. Don't choose wrong ones. Now, we put the sensors into the scene. Select the global position of each object. We will use these to check the ray collision of the right sensors with the outer wall. Don't forget to uncheck the ray collision test only box. Object slot of the ray collision node needs an object to collide with. This will be the outer wall object. Now, duplicate all these nodes, and replace the objects for inner wall and left sensors. We are ready to some action now. Those who know, say that some things are not possible without scripting. So is this. Do not worry. Follow with pleasure. Delete the existing ports and put two boolans here. Then, rename them as you wish. I will use hit out, and hit in abbreviations. Then, for outputs, select two floats and rename them as steering and power. Now, open the Python editor. We identify the output ports in the global line. Steering and power. During the animation, the command lines under the main function run sequentially without stopping. Commands outside and above this only run once at the beginning of the animation. So, it's good to reset the steering value every time the animation starts. We can give some power to motors. I will explain each command line I will write here in detail shortly. Just be patient, and try to get used to it. When you create a condition, the lines below it will be active as long as that condition is met. That's why indentations are so important in coding. Pay attention to alignments. Each condition placed at the beginning of the line has its own commands below it. We use if conditions, else conditions or else if conditions depends on the situation. Now, let's explain the commands we use. In the first line, there is a condition for the outer wall collision to be true. If true, it adds 1 degree increments to the wheels as long as the condition persists. Let's assume the wheels rotate a total of 12 degrees. This else-if condition decreases the wheels by 5 degree increments, so that they return to their original state after contact with the wall is lost. The wheel angles decrease by 5 degrees each time until it is less than 0. There is no problem if it is equal to 0, but if it is less than 0, it must be reset immediately. Commands to hit interior walls, will be the opposite of the above process. Now let's add these codes. Just copy and paste the existing code. But take care of the alignment. Now let's reverse the process. Change the condition hidden first. Then plus signs turn into minus signs turn into plus signs, less than signs turn into greater than signs, and greater than signs turn into less than signs. Connect the ray collision nodes to these ports. We cannot connect the steering and power outputs directly. We need to convert these to radians. Objects such as engines seem to work in degrees, but they work in radians. Follow exactly what you watched. If everything is good, our car will move forward without hitting the walls. Yes. Both sensors work well and the vehicle maneuvers without hitting walls. Let's make a few additions and have fun. Let's do something to stop our vehicle. Take a plane and make it editable. If it is not editable, it will not be detected. Rename it as you wish. Now, copy the collision nodes and replace the objects with these new ones. We will use middle nulls to detect the collision with plane. Create a new boolean port in Python node and rename it. Now, we will write a new condition. If collision is true, then reset the power and stop the motors. Connect it to the Python's port and give a try. Using this plane, you can stop the vehicle whenever and wherever you want. When you move the plane out of the way, the vehicle will continue to travel. Beautiful. Now let's force the vehicle to reverse. Let's create a plane again and give it a name. We will use the same collisions. Replace the plane only. Then create a boolean port again. Rename it. If this condition happens, we reverse the power and reset the steering angle. This make the car go back every time we put this plane on road. When we move this plane out of the way, the positive thrust value we described before will be replaced by this negative value and the vehicle will move forward. Will it work? I'll be surprised if it doesn't work. Hey honey, back off. The road is blocked. Sometimes you get stuck. Use one of these planes to continue. Folks, that's it for now. I hope you liked it. It was a bit of a long video, but I couldn't have explained it in a shorter way. Thanks for watching. See you later.